today what we're going to do is we're going to take a look at the path of a projectile object. So that's anything that's flying through the air, a ball, a person, you know, your pencil. Yeah, Cam, watch it. Don't throw that. Just kidding. All right, now, basically, we have a path of a rocket or a baseball. Follows this general equation. So the general equation is given by this. H is equal to negative gt squared plus v0t plus h. So the first part of the equation basically talks about how when you have a ball or something, a ball or anything that is of mass, and you drop it anywhere close to the Earth, both objects will travel at the same speed and increase their speed as they fall. And they will both hit the ground if they start at the same height at exactly the same time. And that's all due to the acceleration due to gravity. And that whole part of the first equation talks about that. It's basically talking about how gravity actually affects the motion of an object as it drops from above the ground. Now, the V0t, that has something to do with Newton's idea that if something's in motion, it continues in motion until it actually gets another force applied to it. Okay? So think about it. If you're skating and you're skating really fast and then you stop skating, you just keep traveling and traveling and traveling and traveling until you hit the boards, right? The only reason that you stop is that the force of the boards pushing against you stops you dead in your tracks. And that's what the V0t is actually talking about. The V0 stands for the initial vertical velocity of something as it moves. Okay? Now, remember, this is about projectile motion above and below, right? So now, what I want you to do is I want you to take a look at this thing. The H0 represents the initial height of the object. One of the things that you should realize is that anything that is up is considered positive. So if something is acting up or moving in an upwards direction, it's considered positive. Anything that goes down is considered negative. So if you look at the first part of this equation here, you'll notice that we have negative 1/2 gt. So if you think about it, the acceleration due to gravity is about 9.8 meters per second, right? But what's happening is that entire quantity is negative. It's acting against anything that is moving up to pull it back down. That's where we get the concept of whatever goes up must come down. But in this case, the force due to gravity is 9.8 meters per second. We're just dealing with that as a pure unit. All right, and that force, that acceleration due to gravity eventually overtakes what happens on this and pulls our object back down. Okay, now here's what I'd like you to realize. This basic equation allows us to calculate the height of any object as it moves through the air. Right? Now, if you think about it, when a ball gets kicked off the ground, it follows a projectile path, which is really a parabola, also known as a quadratic. Hey, how you doing? So, if I'm dealing with something like this, this basic equation is useful in the sense that as long as I know the constant, the gravitational constant, the gravitational acceleration of any planet I'm on, okay, I can figure out the height of any object if it's thrown in the air. Okay, so now let's take a look at this problem here. It asks us to create a model for the height of a toy rocket that's launched upwards at 60 meters per second. Now, it's launched upwards at 60 meters per second. Isn't that a velocity? So here's what we're going to do. if we're using this, right, that's our basic equation there, right? So its initial velocity for this thing is up 60 meters per second. So that is plus 60 meters per second, right? And remember, the gravitational constant based on this equation is always 9.8. Now, and in this case, it also says that its height is 3 meters above the ground. So that means this part here is 3 meters. So now, when we substitute this information into our equation, we get the following. And we end up with this equation when we substitute directly in. So now, what I'm going to do is I'm going to go and simplify the front of this part here, to make a nice quadratic for us to work with. So in this case, h is equal to, well, negative 4.9 t squared plus 60t plus 3 as our final quadratic. And you'll notice that we took negative a half, multiplied by 9.8 to get negative 4.9 plus 60t plus 3 as our basic equation. So now what we're going to do is we're going to take that information and we're going to use it to do some calculations. Now, this problem asks us, how long would the rocket take to fall to Earth? Okay, so if the rocket starts flying, remember, time is equal to 0 there, right? Right? But you need to recognize that the time is always greater than or equal to 0. It's never less than 0, okay? This is an important concept for when we're dealing with projectile motion. We can't go back in time to go and see where the thing goes, but for a parabola, there is, in this case, always two x-intercepts, right? Now, let us start. So our basic equation, our objective function is h is equal to negative 4.9 t squared plus 60t plus 3. Now, when it says how long is it going to take to hit the ground, basically what you're doing is the following. You're using the fact that when it falls to Earth, we hit in the ground. All right? Now, when we hit the ground, h is 0, and Bob's your uncle. So now all we're going to do is substitute that into our equation. So now we have 0 is equal to negative 4.9 t squared plus 60t plus 3. Now, doesn't that look like our basic equation? 0 is equal to ax squared plus bx plus c, right? Where a is equal to 4.9, b is equal to 60, and t is equal to, and 3, c is equal to 3. Oh, sorry. A is negative 60, negative 4.9. So let's just do that right now. So now what we're going to do is we're going to use my favorite calculation. Now, you could either take this and try to factor it using completing the square in this equation here, or you just go straight to quadratic formula, and you're going to have the following. So now we have b squared minus 4ac is going to equal. So we have 3,658.8, and that means it's greater than b squared minus 4ac is greater than 0, so it means we have two solutions available to us. Now, in these instances, a lot of the times you're going to have one instance where you have an inadmissible or an erroneous solution or an impossible solution because we can't have time less than 0. On to part 2. Let's substitute into the quadratic form. And substituting into the quadratic equation, we have something that looks like this. And then when we split our problem up, we're eventually going to get the following. Well, we had one little mistake there. Just make sure that when you're using your variables, x's are really t's in this case. So t is equal to that equation. And you end up with t is equal to negative 0.05 seconds or t is equal to 12.29 seconds. Now, remember that we started by saying h was equal to 0 here, right? So this means it hits the ground. All right? Now, because we hit the ground, it's either this one, which is negative 0.75, and if I look at this one is impossible because we cannot have times which are less than 0. But this one here tells us that after 12.29 seconds, we actually hit the ground. So we'd say that it hits the ground at 12.29 seconds. Now, because this is one of those in-depth videos I told you about, we have a few things we have to do. Now, recall, take a look at this problem here. We're looking for the maximum height. Our original equation is given by this. Negative 4.9 t squared plus 60t plus 3. There are ways for you to go and factor this. You can go and factor this using using completing the square to do this problem, but I'd suggest not. You could complete the square. But why would you? Didn't I teach you something? I told you that the axis of symmetry was based on this equation, negative b over 2a, right? So if I wanted to, I could tell you right away, go find me the maximum height and when it happens. So if I go and punch this in, I know that from my equation, my b value is 60, my a value is negative 4.9, and I just plug that into my equation. So the AOS for this equation is going to be t is equal to negative 60 divided by, well, 2 times negative 4.9 is negative 9.8. And when we calculate that, our final answer is going to be t is equal to 6.12 seconds. So now what we're going to do is we're going to take that information, we're going to sub into basically h is equal to negative 4.9 t squared plus 60t plus 3. Doing that, you're going to get your h value equaling, and now that we've we back substitute back into our equation, we end up with h being 186.67 meters when t is 6.12 seconds. It's not that difficult. Now, our last problem of the day is, over what time interval is the toy rocket greater than 150 meters? So, basically what you're going to do is you let h is equal to 150 and solve. So now we get 150 equals this, and what we're going to do is we're going to take this 150 and move it to the other side and add it to 3. So it ends up being negative 150, so we get the following. And we get this. And based on this, our A, B, and C values are the following. Now, when you do this, you're going to go and punch all this into the quadratic formula, because this is a very difficult problem to solve. And when you end up with that, you're going to end up with 2 values for t. So you're going to have the solutions, and you're going to have t equaling something and t equaling something else. And we end up with this for our t values. Now, based on that, what you're going to do is you're going to say, therefore, the ball is above 150 meters for, or you want to say between, 3.39 seconds or 8.86 seconds. And the reason for that is this. Your parabola starts at 3 meters above the ground. It reaches a maximum and then comes back down. And what we have here is points between here and here. And these two values of t are going to be down here, which is 3.39 seconds and 8.86 seconds. So basically, we're looking for all the times from here all the way to here. And based on that, we're pretty much done. All the work for this lesson. Your homework is based on these 3 sets of questions that are left over. Now, based on the work that we're going to do, there's lots of problems to do here, so try them all. They should be doable. Work on these questions for day 2. See what you've got. Good luck, guys. And Larry's laughing now because we have nothing left to do other than this and the review. Take care, guys.